Paula,
I'm Alexis.
and we have Math Practice 8 looking for and expressing regularity in repeated reasoning. Our first example is a long division problem. So students can use repeated reasoning in a number of different ways. First, starting out when students know that they are doing division, they know that the number is going to be smaller in order to divide and create groups. So if my problem is 496 divided by 12, the students would see a repeated process whenever they're doing that long division problem. So they would start out by looking at how many times 12 would go into 49. So, and then after that, they would have a repeated process of multiplying and then subtracting that number. Once students see that 12 will go into 49 4 times, then they would multiply the number by 4 by 12, and then with a product of 48, they would then subtract from 49. This process is continued and creates regularity within the problem. When students get to the end of the whole number, they have to continue dividing because they're not doing like a remainder type problem. We want them to continue to divide to get a decimal. And so they have to provide zeros to be able to continue their subtraction, their repeated subtraction and multiplication. So once they've created or pulled down that zero, they will see that 12 would go into 43 times. And once they repeated that subtraction, they would see that the difference is yet again 4. Once they see that difference is 4 again, they have to pull down another 0. So they would see how many times does 12 go into 40, and they would see that it goes in 3 times. They would find that 3 times 12 is 36. They would subtract and get 4 again. Once they see that pattern, I would hope that the students would see a pattern of that and see that their number of 496 divided by 12 is 41.3 repeating. So that number that they're subtracting just continues to come out as repetition.
So our second example is an example requiring polygons and how to find the sum of interior angles inside a polygon. The repetition here is that when you're given a number of sides of a polygon, then you can create 2 less than that number of triangles inside the polygon. So basically in the picture I drew triangles and then I drew a square. 2 of the triangles fit inside of that square. So that polygon has 4 sides. The number of triangles that you can fit inside is 2. 2 is less than 4. So then I drew a hexagon with 6 sides and notice that I can draw 4 triangles inside that shape. So 2 less than 6 was 4. And then again with the octagon is the same thing, 8 sides, you can draw 6 triangles. Using the pattern, I figured out that the number of sides is always 2 more than the number of triangles you can fit inside of it. And so when students do that, they can figure out the equation n minus 2 times 180 to get the entire sum of the interior angles. Not only does this incorporate our Math Practice 8, but also the first one we did, which is making sense of problems and persevere in solving them. So by figuring out how many triangles can be created from this single vertex, students can make sense of how to create the expression and how they came up with it, so they can understand it better.
So with our 2 examples, we are looking at Math Practice 8, looking for and expressing regularity in repeated reasoning. So first, students notice repeated calculations. So students are aware of repetition when it's modeled and intentionally connected. So it's the teacher's job to model that and intentionally show that there's repetition happening. And this allows students to make those connections when working on higher level problems. They're also looking for general methods and shortcuts. So whenever Alexis was looking at the triangle and the polygon, they were able to come up with a formula that then they wouldn't have to count the sides. They could just use that formula, and so they're creating their own method of finding the total angles sum, and so then they're creating that shortcut as well. Students are also maintaining an oversight of the process while also staying attentive to the details. So students are also able to look at the details of the process, but also looking at the process as a whole. So they're able to see what pieces work in certain scenarios and what pieces don't. Students also evaluate the reasonability of the answers that they get. So whenever they are trying out new shortcuts or they're looking at new formulas, they can have a repeated reasoning of, does this actually make sense to what I'm trying to solve?
So again, with the SIOP model, as discussed in the first collaborative presentation that we did, is a sheltered instructional observation protocol. It's mainly used for educators to help ELL learners, English language learners, and help improve their academic performance. It's also important to note that this model is not only useful for ELL students, but also students in general. It really makes sure that you pay attention to what you're teaching and slowing it down and making sure that they all understand it. So we'll explain that.
So the first part of the SIOP model is lesson preparation. So creating a clear objective for students to know what they are learning and how they will learn it. As an educator, it's our responsibility to create that lesson and have a clear idea of what we want our students to learn. If we're not sure what we're going to be teaching, we shouldn't be creating the lesson yet. If we're not sure what our objective is going to be, we shouldn't be teaching a lesson yet. So with the Math Practice 8, I have to focus my lesson on that and only that and make sure it's clear. I also, with the SIOP model, want to look at building a background. I think this is super important with Math Practice 8 because when I'm presenting a new concept to my students, I want to activate their prior knowledge by really understanding what each student already knows so that I can build off of that. So if I want to create repeated reasoning, I have to make sure that they know something beforehand. So, for example, whenever I was doing the long division problem, if I know that my students don't grasp subtraction in number sense at all, or really division at all, I shouldn't be surprised if they don't see the pattern that 40 minus 36 is always going to be 4, or that 40 can only be divided by 12 3 times, with a few left over. So if they don't see that that's going to happen over and over again, they're not going to see the repetition, and they're not going to see that when they divided 496 divided by 12, it's going to come out as a repeated decimal. With comprehensible input, that's another part of the SIOP model, and this goes back to lesson preparation and building a background. If I'm creating a lesson that is not appropriate for my students, they are either going to think I'm talking to them like they're dumb, or they're not going to understand anything that I say. So if I'm using the correct vocabulary and introducing new vocabulary or content terms that they will need to know in order to be successful for that objective, then I can know that my lesson is prepared and that I know the background of my students. The fourth part of the SIOP model is student strategies for success. So presenting many methods to finding a solution to the problems presented. So for example, with the long division one, students would work out the long division problem and see the pattern after they've done the subtraction and they've done multiplying and they've done division and they've repeated that process, and then also seeing a repeated decimal for their answer. I could also reassure them with the awareness that if I type this into a calculator, they would be able to see that repeated addition and know that, oh, this actually does make sense. And so I can show them different strategies for them to be successful and have that reassurance.
So the next one is interactions, creating opportunities for students to collaborate and use manipulatives to create a visually engaging experience. So for the polygon and triangle example that I used, it was really important for the students to see the polygon and see from one vertex how many triangles they can make. So it's really important for them to be able to draw that out and use their resources to actually see it happen, because if you just explain it to them, it's not going to make a whole lot of sense. Lesson delivery, the flow of the presented lesson is smooth and easily understood. This is really important for Math Practice 8 especially. It's important to make it as easy to understand as possible, for them to understand that a process is being repeated and why it happens and how that makes sense to them. Practice and application, the student or the teacher allows an optimal amount of time for students to engage with new content presented. So in order for the students to really grasp the concept of something being repeated in a formula like we did, especially in my long division example, the educators might give them an ample amount of time to work through the problem at their own pace. So when you give them the example in class, make sure that they work through it on their own independently until they have that like aha moment. So when they really understand it, really get that it's repeating something over and over again. And then review and assessment is the last part of the SIOP model. Repetition is everywhere in math, whether we see it or not. And this math practice really opened my eyes to that. I'm trying to look for examples and stuff. I realized a lot of things is repeating. In order to assess students on being able to look for repeating patterns and problems, we need to make sure that they can physically see the repetition and that it makes sense to them and they understand what's happening and why it's happening. And that's our math practice 8.
Thank you.